Good afternoon. Today we are going to discuss about a topic in chemical equilibrium, that is lechatelier principle. Right. So before understanding why do we use lechatelier principle, to understand this you need to know two things. First one is, let us take a system, okay, right, or system or a equation which is reversible and which is in equilibrium, right. So A gives B and B gives A. Let us take this system. Now this system is in equilibrium, right? Right? This system is in equilibrium. So what is so special about equilibrium? Right. So at equilibrium, rate means speed. Rate of forward direction will be equal to rate of backward direction. Right. So at equilibrium, rate means speed here. Speed of forward direction will be equal to speed of backward direction. So this is your forward direction and this is your backward direction. So this is the first point. So to understand lechatelier principle, you need to know two things. One is this point. So at equilibrium, rate of forward direction and rate of backward direction will be equal. That means equilibrium is going to support forward and backward equally in terms of speed and talking. Okay, so no one is given partiality here or no one is given priority here. Forward and backward both are given equal priority. Okay, so no one is given partiality, right? So that is the first point. So both are supported equally, right? Second point is, at equilibrium, system cannot change physical quantities like temperature, pressure and concentration on its own. What does it mean here? That means this system cannot change physical quantities like temperature, pressure and concentration at equilibrium on its own. So it cannot change these things on its own. Okay, are you following? So at equilibrium, temperature, pressure and concentration, physical quantities of a system cannot be changed. It remains constant. Are you following? Right. But you can do one thing. So the system is not changing its physical quantities, then means you can externally change these physical quantities. Right. So you can increase the temperature or you can decrease the temperature of the system. That means you can change the temperature of the system, or you can change the pressure of the system, or you can change the concentration of the system externally. So when you do that, what equilibrium does, that will be explained with the help of lechatelier principle. Okay. So when externally physical quantities of a system got disturbed or changed, then what equilibrium does, that will be explained with the help of lechatelier principle. Okay. So this is the basic funda behind lechatelier principle. Right. Right. So let us see how that lechatelier principle is going to work. Okay. Let us take the same example. A gives B. Now let us take this system is in equilibrium. Right. And externally I am changing the temperature or pressure or concentration, okay, of a system. So system cannot change these things. That remains constant at equilibrium, just now we discussed. And I said that equilibrium is going to support forward and backward equally. No one is given priority here, right? But when when physical quantities are disturbed externally, that means if you are changing the system's temperature, pressure and concentration externally, then equilibrium will get disturbed. Now when equilibrium is getting disturbed, now equilibrium is not going to support forward, backward equally. So equilibrium will either support forward more or backward more in order to remove this change. So that is your lechatelier principle. So that is the explanation of lechatelier principle, or you can say a definition of lechatelier principle. So when a system is in equilibrium which got disturbed due to the external changes of temperature, pressure and concentration, then equilibrium will either support forward direction or backward direction, or support, you can say, or shift, or you can say favor forward or backward more in order to remove this change. So that is your lechatelier principle. And if you look at your textbook definition, if a system is in equilibrium which is subjected to change in its temperature, pressure and concentration, then equilibrium will either support or favor or shift in either direction, either forward or backward direction, in order to remove this change. So that is your definition of lechatelier principle. Okay, I think everybody understood what is this lechatelier principle. So before discussing about each and every factor, one important funda should be remembered, and that funda is going to help you in all the cases. So the funda is, look here, see how you can change the things, how you can change the temperature, pressure and concentration. The change can be either you increase or decrease, no? Right. So externally, if you are increasing means, then equilibrium has to support in the decreased side so that this will be removed. So that is the funda. So when you are externally, if you are increasing, then equilibrium has to support in decreased side. If in external, if you are decreasing means, then equilibrium has to support in the increased side. Then only this will be removed. Are you following? So this should be remembered. So that is the basic funda. Are you following? So now let us discuss each and every factor. So don't forget this basic funda. So when you are trying to change, or when you are trying to change by increasing, then equilibrium is going to support in the decreased side, opposite side. Okay, right. So let us discuss one by one factor. Right. So first factor, temperature. Right. So before discussing about first factor, temperature, so let us understand how to identify if a reversible reaction is given to you. So how to identify which side is endothermic and which side is exothermic. That I'll explain first. So A plus B, this is a reversible reaction, is giving you C plus D, and he has given you plus heat. If the equation is like this, what does it mean? Right. So in forward direction it will be exothermic, and in backward direction will be endothermic. Right. So if the equation is like this, plus heat is mentioned, that means forward direction it is exothermic and backward direction is endothermic. Are you following? Right. Instead of he is giving you plus heat, if he is writing you delta H, is writing you delta H. So delta H, simply is written delta H, and he is written delta H is negative. Delta H is negative value. So which means that again forward direction will be exothermic and backward direction will be endothermic if delta H is negative. Instead of negative, if he is giving you positive, which means that forward direction will be endothermic and backward direction will be exothermic. Are you following? Right. So like that you can identify whether in a given reversible reaction forward direction is exothermic or backward direction is exothermic, forward direction is endothermic or backward direction is endothermic. Okay. So is it clear? Right. Now let us discuss about the first factor. First factor, temperature. Right. So let us take a system. Now this is the system which is in equilibrium. Right. So this system can have forward exo or backward exo, forward endo or backward endo. So simply I am writing that delta H is negative means what does it mean? It is exothermic, and delta H positive means it is endothermic. Are you following? Right. Now externally I am increasing the temperature of the system. Externally I am increasing the temperature. That means externally I am disturbing. Now equilibrium will get disturbed. Equilibrium will get disturbed. So when equilibrium get disturbed, what did I say? So externally it is increasing. So equilibrium has to support in the decrease side. Sir, how to identify whether exo or endo increase or decrease? Very simple. Exo means you take it is increase. Endo means it is decrease. Now over. So when temperature is increased, then equilibrium will shift in which direction? Decrease side. Now what is decrease side? Endothermic. So what is the statement? Right. When temperature is increased, then equilibrium shift in which direction? Endothermic side. When temperature is decreased, then equilibrium shift in which direction? Exothermic side. Are you following? And sir, forward exo, backward exo, that depends upon the equation. So जो equation देता है उसके ऊपर depend होता है. Okay, so we'll take an example, right? Yeah. So but general statement क्या है? Yeah, when temperature is increased, then equilibrium shift in which direction? Endothermic side. When temperature is decreased, then equilibrium shift in which direction? Exothermic side. Are you following? Right. लॉजिकली आपको ये याद कर सकते हैं, जैसे कि देख टेम्परेचर हम इंक्रीज कर रहे हैं, वेर इंक्रीजिंग टेम्परेचर, तो इक्विलिब्रियम वो टेम्परेचर को डिक्रीज करने के लिए चाहता है, तो इन विच डायरेक्शन इट विल डिक्रीज? इन एंडोथर्मिक साइड ओनली इट विल डिक्रीज. नो, एंडो मींस टेकिंग हीट. सो जब इंक्रीज हो रहा है तो एंडोथर्मिक वो लेता है, सो उसकी तरफ वो सपोर्ट करता है इक्विलिब्रियम. और यू फॉलोइंग? राइट. सो व्हेन टेम्परेचर इज इंक्रीज, इक्विलिब्रियम शिफ्ट इन द एंडोथर्मिक साइड. व्हेन टेम्परेचर इज डिक्रीज, इक्विलिब्रियम शिफ्ट इन द एक्सोथर्मिक साइड. Okay, basic funda. Opposite direction it has to support, right? So we'll take one example. You get more clarity. Right. So let us take this formation of ammonia. Let us take this example. Right. Yeah. So just now I said, if delta H is negative, what does it mean? Tell me. So in forward direction it is exothermic, and in backward direction it is endothermic. Right. Yes. So when temperature is increased, then equilibrium shift in which direction? Endothermic. Which side is endothermic? Backward direction. So for this reaction, when temperature is increased, the equilibrium shift in the backward direction. When temperature is decreased, then equilibrium shift in the forward direction, because exothermic side. Are you following? So like that, in this equation forward is exo, that's why when temperature is increased, equilibrium shift in the backward direction. When temperature is decreased, equilibrium shift in the forward direction. If it is changed, if it is positive, forward will be endo, backward will be exo, then it will be changing. Are you following? Right. Let us take the second factor, pressure. Pressure, right? Yes. So let us take the system. Let us change the coefficient of the reactants. Okay. Now 2 moles of A is giving you 1 mole of B. So why I am changing, I will tell you. Don't worry. Right. Now this is in equilibrium. Right. So this is in equilibrium. Right. Now externally I am going to change the pressure. Either I can change the pressure by increasing, or I can change the pressure by decreasing. Sir, with temperature, you have said that endo is decreased and exo is increased. Sir, how to identify with pressure, sir? Very simple. See, generally pressure is related with moles, no? So, if you take this container or if you take this room, if you increase the number of moles of particles, then they will collide with the walls and they increase the pressure, no? Right. So, you can explain pressure with moles. Sir, how to identify moles? Look at the coefficients. So, in this example, in forward direction, what's happening, you tell me? 2 moles of A is giving you 1 mole of B. 2 moles of A is giving you 1 mole of B. In the backward direction, 1 mole of B is giving you 2 moles of A. 2 moles of A. Are you following? Right. So in the forward direction, what's happening to the moles? Moles are decreasing. Okay. What's happening to the moles in the backward direction? Moles are increasing. So 2 moles are becoming 1 mole. So moles are decreasing in forward direction. 1 mole is becoming 2 moles. Moles are increasing. Got it? Now, when pressure is increased, just now I said equilibrium will support in the opposite direction. Okay. So when pressure is increased, so equilibrium has to support in which direction? Pressure increases. So it has to support in the moles decrease side. Okay. So moles decrease side. So what is the statement? When pressure is increased, equilibrium shift in the moles decrease side. When pressure is decreased, equilibrium shift in the moles increase side. Okay. And in this equation, forward is decreasing and backward is increasing. That may change because दूसरे इक्वेशन में रिवर्स भी हो सकता है यार. सो खाली ऐसे याद रख लो कि जब प्रेशर इंक्रीज होता है तो इक्विलिब्रियम किस तरह फेवर कर रहा है? डिक्रीज साइड. सो मोल्स डिक्रीज साइड फेवर करेगा. सो व्हेन प्रेशर इज डिक्रीजिंग it will support towards moles increase side. Are you following? Right. Very simple. So this is the basic funda. Sir, if the moles are not changing, if the moles are not changing, what's happening? One mole is giving one mole, right? So when moles are not happening, when the moles are not changing, when pressure is increased or pressure is decreased, nothing is going to happen to equilibrium. So equilibrium will not get affected. Okay, na? So when moles are not changing, equilibrium will not get affected. So that is the second point to be remembered in pressure. Are you following? Right. Third one, volume. Okay, volume. And you know that volume will be inversely proportional to pressure, right? So when you are increasing the volume, that means pressure is decreasing. So when you are increasing the volume, pressure decreases. When pressure decreases, equilibrium shift in the moles increase side. Very simple. When volume is decreased, that means pressure increases. When pressure increases, equilibrium shifts in moles decrease side. That means equilibrium will favor towards moles decrease side. Are you following? So volume is inversely proportional to pressure. Very simple. Third factor is very simple. So you compare with pressure, you will get the thing. Right. Fourth factor, concentration. Right. So concentration means there is a doubt, sir. Concentration of reactants or concentration of products? So concentration means we have two things: reactants and products. Reactants you may change by increase or decrease. Products you may change by increase or decrease. There are two cases, two possibilities. Right. Now let us take a system which is in equilibrium. Right. This is in equilibrium. So for any reaction, look here, in forward direction, for any reaction in forward direction, for any reaction will be taken. For any reaction in forward direction, reactants will decrease and products will increase. Yes, because in forward direction, reactants will use up, no, products will be formed. So reactants will be decreasing, products will be formed, right? And in the backward direction, reactants will be increasing and products will be decreasing. Are you following? Products will be decreasing. Why? Because in the backward direction, these products will be used up and reactants will be formed. Are you following? So that's why reactants increases and products decreases. And this funda will be used for all the reactions, right? Because if you talk about pressure and temperature, that depends upon the equation. But for concentration, this remains same for all the equations. Whatever equation you take which is in equilibrium, you can use this relation. Now over, when concentration of the reactant is increased, then equilibrium will shift in which direction? You are increasing, it should support in the decrease direction. So which side is decreasing here? Forward is decreasing. So when concentration of reactant is increased, then equilibrium shift in which direction? Forward direction. When concentration of the reactant is decreased, then equilibrium shift in which direction? Backward direction. Because if you are talking about reactants, look only reactants. If you are talking about products, look only products. Right? Very simple. Concentration of the reactants is increasing, then equilibrium shift in the backward direction. That means equilibrium shift in the opposite direction. So what is opposite direction here? Forward direction is opposite. Okay? So इधर increase हो रहा है तो decrease की तरह support करना है. So किधर decrease हो रहा है? Forward direction में decrease हो रहा है. Right? Similarly, when concentration of the product is increased, then equilibrium shift in the backward direction. When concentration of the product is decreased, then equilibrium shift in the forward direction. Only funda. अगर इधर increase हो रहा है तो इधर decrease होना चाहिए बस. So when it is increasing here, it should decrease here. That is the basic funda. Are you following? Right. Very simple. Okay. So this is the concentration. So no need to buttify anything. Just you can have a logic here. With this logic, you can understand the things. Right. So let us go for the last factor, which is very important factor. Most of them will get confused. Fifth factor, that is addition of inert gas. Addition of inert gas, very, very important. Alright. So let us take a container. Yeah, this container is having a reversible reaction. This is the reversible reaction which is in equilibrium. Now, What is inert gas? You know, the non-reacting gas, right? So this inert gas is added to this container, right? So you can add this inert gas in two cases. First case, at constant volume. Second case, at constant pressure. Yeah, two cases: constant volume, constant pressure. So let us take first case, constant volume. I'm not going to change this volume of the container. So that is a constant volume. Are you following? So at constant volume, I'm trying to add the inert gas, right? So the volume of container is not changing. So when you're adding inert gas inside this container, the number of gas particles will increase, no? Right? So when number of gas particles are increasing, the pressure, the total pressure of this container is going to increase, right? The total pressure of the container is increasing. If the total pressure of the container is increasing, does the number of moles of reactants and products are getting affected? No. That means I'm talking about in terms of pressure. So in terms of individual pressures of A and B, does they are getting affected? No. So the individual pressures of A and B will remain same, but the total pressure of the container is increasing. Total pressure container is increasing, but individual pressures are not getting affected. When individual pressures are not getting affected, equilibrium is not going to get affected. Are you following? Right. So very, very important point. So if you are adding an inert gas at constant volume, the total pressure of the container is increasing, but the individual pressures of A and B are not changing. So when individual pressures of A and B are not changing, the pressure is not getting affected. When pressure is not getting affected, there is no problem to equilibrium. Are you following? Is it clear? So addition of inert gas at constant volume will not have any effect on the equilibrium. Very simple logic. So logic is total pressure is increasing, but individual pressures, partial pressures of A and B is not changing, right? Individual pressures of A and B. So partial pressures means what? Individual pressures of A and B are not changing, right? Now let us take the second case, right? Second case. A second case at constant pressure. Okay. Constant pressure, very, very important. Okay, constant pressure. That means I want to keep pressure constant. Now look here. Let us say that before adding inert gas, it is having 1 atm pressure. This container is having 1 atm pressure, which is at equilibrium. 1 atm pressure before adding inert gas. I'm adding inert gas. Just now I said when you're adding an inert gas, pressure will increase because more number of gas is entering into the container, right? Now what is the condition? We should not change the pressure. So to not change the pressure, what we should change? Right, we should increase the volume. Right. So if you want to keep that 1 atm only, then what we should change? Volume. If you are not changing the volume, automatically pressure will increase. But the condition is that pressure should be constant, right? So in order to balance the pressure, I need to increase the volume. When you increase the volume, the pressure is not getting affected there. Are you following? Right. So at constant pressure, if you are adding inert gas, what we should do? We should increase the volume, right? So when you are increasing the volume, the concentration, because moles per volume is a concentration, no? The concentration of reactants are changing, reactants and products are changing. The concentrations of reactants and products are changing. When concentrations are changing, equilibrium will get affected. Are you following? Equilibrium is going to get affected, right? So then in which direction the equilibrium is going to support? Very simple. So what's happening here? Volume is increasing, right? So volume is increasing. Just now we discussed, when volume is increasing, then equilibrium shift in which direction? Equilibrium shift towards moles increase side. Just now we discussed, no? Because when volume is increasing means what we consider? Pressure decreases. When pressure decreases means when pressure decreases means equilibrium shift in which direction? Moles increase side. Are you following? So just now we discussed the point. Are you following? Right. And that you have to remember one point. The coefficients, very, very important. The coefficients of the reactants should change. If the coefficients of reactants are not changing, what's happening? Whether you increase pressure or you decrease pressure, it is not going to get affected. Are you following? Right. So at addition of inert gas at constant pressure, if moles are changing means, coefficients are changing means, then equilibrium shift towards moles increase side. Are you following? Okay, na? Right. So if moles are not changing means, At constant pressure, if you are adding inert gas, nothing is going to happen to the equilibrium. It is not going to get affected because moles are not changing. When moles are not changing, pressure is not going to get affected. When pressure is not going to get affected, equilibrium is not going to get affected. Very simple logic. Are you following? Okay, so once again, the last thing is, see, when you are adding an inert gas, if you want to keep the pressure constant, we should increase the volume. So when you are increasing the volume, what's happening here? Increasing the volume means concentration is getting changed here. So when concentration of reactants and products are getting changed, equilibrium will get disturbed. So when equilibrium is getting disturbed, then that means equilibrium has to favor either forward direction or backward direction. Okay, so in which direction it is going to favor? So you are increasing the volume. When volume is increasing means, that means pressure is decreasing. When pressure decreases, equilibrium shift in which direction? Moles increase, right? But this point to be considered when coefficients are not same. When coefficients are same, then pressure is not going to have any effect on equilibrium. So when coefficients are different, use this concept. So when coefficients are different, then equilibrium shift in which direction? Towards the moles increase side. Are you following? Because we are increasing the volume. Increasing the volume means pressure decreases. Are you following? So this is the logic behind lechatelier principle. Very, very simple. Thank you.